Okay, so we want to find the work needed to pump all of the water out of a tank out of this little hole. So as usual, we're going to grab a slab. Now notice that the slab, so if you grab just a random slab, um, uh, right here, it's going to be in the shape of a rectangle of thickness delta y as usual. Okay, so let's place the axis right along the center of the cylinder. So I've got this is 0. So from here to, let's say, here, so that's going to be y. Let me blow that up, actually, because I think it's a little hard to see. So this is the axis. And so imagine your slab is located at this point right here. And so then from that point to the side, that's the width of the rectangle. And so then if you draw a line from the center up to the edge of the rectangle, that's going to be the radius r. And then from here to here is y. So that means that the width is equal to the square root of r squared minus y squared. So then that's of course only half of the width. So the entire width of the rectangle would be twice what w is. So twice this much. Okay, so then my next task is to find the volume of the cylinder. So the volume is going to be 2 times the width, which is square root of, or w, not twice the width, but once the width, twice this w that I found right here. R squared minus y squared times L, the length, and then times delta y. Okay, so then the work needed to move this slab is going to be the volume, which is 2, I'm just going to write it 2L square root of r squared minus y squared, delta y, cubic meters, times the density of water, 1,000 kilograms per cubic meter, times gravity, 9.8 meters per second squared, and then times the distance that it needs to travel. So to go from where it is, which is y, up and out, is going to be r minus y meters. And notice this applies if it's above or below the x-axis. Okay, so then meters cubed cancel, kilograms meters over second squared, that's a Newton, and so all of these put together is a joule. So then if I put this all in, what I'm going to get is the total work is equal to the integral from negative r to r of, actually let me backtrack a little bit. Let me multiply the constants. So it's going to be 19,600 L integral of from negative r to r of the square root of r squared minus y squared times r minus y dy. Okay, and so then the way we're going to approach this guy, it's in two parts. So what we want to do is we're going to have to break this guy up a little bit. So we're basically going to distribute the r and the y, and so we're going to break this up into two different integrals. So this is going to equal to 19. Let me do 19,600 L, and that's constant, times, and then r is a constant, so it's going to be r times the integral from negative r to r of the square root of r squared minus y squared dy, and then minus the integral from negative r to r of y square root of r squared minus y squared dy. Okay, so I'm running pretty close here. So basically this r is this one that you distributed, and then this y is this one. Now to actually do these, this one right here, this one we're going to use integration by substitution. And then to do this one, you actually have to recognize this as a circle. So let's that one's a little bit trickier, you have to remember, but let's do these separately up here. So let's do it up here. Okay, so let's do this one first. So this one's the easiest one, as long as you recognize it. So r integral from negative r to r of the square root of r squared minus y squared. This right here is a circle of radius r, half circle. So if you're going from negative r to r, so this guy looks like, looks like this, negative r to r. So this is just 1/2 pi r squared, and then times that r, that's going to be pi r cubed. So you don't even have to use the fundamental theorem of calculus for that one. Now this other one, you can do it using integration by substitution. I'm not going to, because in reality, also another thing that you might recognize is this function. This is an odd function, and it's the interval is symmetric about the origin, and so this guy is just going to equal to 0, because the positive area and the negative area are going to cancel each other out, and that'll just give you 0. But you can do it using integration by substitution, and you'll get the same thing. So then what we have is this guy right here, 19,600 L times 1/2 pi r cubed. So if we summarize this, we would get 9,800 pi l r cubed. Joules, of course. And that's it.